Barbara continues. I'd like to make some questions to you. You said first, can you come back to the simulation in which you changed the depth of the bulkhead?
Of course.
You said that you have gravitational waves, right?
Yes.
Do you agree with me that for gravitational waves, you have the wavelength changing if you change the depth of the bulkhead, the depth of the water? No, this is not the simulation. I think it's the first one you showed. Okay, do you agree with me that for gravitational waves? No, not actually. But do you agree with me that for gravitational waves, you have the wavelength changing with the depth of the water?
The wavelength?
Yeah. Yes or no, please. I have some more questions.
Which? Wavelength of the wave of the,
of the water.
I think that it's irrelevant because in our
Oh, you said that it doesn't change. So just yes or no, because I have some more questions.
No.
Okay. You have a simulation. I thought it was pretty good, but what are the equations you use for that? Because we want to see the validity of if that applies to the reality.
What do you want to see simulation? Or?
Yeah. What's the equations you use for that?
Well, it's for most of our simulations. We have just a simple refraction from Snell's law, like.
No. Please, write on the paper.
Okay. This morning you told us to write on the paper.
Okay, that is portion, the last graph that you've shown us. What it was supposed to tell us about it? I mean, you have some theoretical points. Does it form a tendency? What is it dependent on? What does it mean? And
well,
why
it
have
depends. Yes, this standard deviation versus average intensity is a statistical measurement for what's the contours of the bright patterns. Because when you have high standard deviation, if you know what it is, you know what standard deviation is.
Yeah, I know what standard deviation is.
So when you have high standard deviation,
why does it have the theoretical reference?
The time this is discussion, and the time for questions is finished.
What's this?
Excuse me, please. Your time for question is finished.
Sorry. Area. My name is Barbara, and I'm going to oppose the problem 5 brackets. First, in their theory, they made a 3D simulation, although we don't know which equations they are using actually for those kind of predictions, the mathematical model. They vary some parameters like the amplitude, but we don't see, unfortunately, we don't see any clear conclusion of the comparison between the theoretical model and the experiments, and about the whole phenomenon which the objective is investigate the change of the patterns, like the geometry or other parameters. So the positive points, they talk about the gravity and the capillary waves, which exists in the phenomenon that could influence the pattern in the bottom of the tank. They talk about the superposition of the waves, so the interference of the water reflected waves. They made a 3D simulation, although I want to emphasize we don't know where the simulation comes from. They tried to make a theoretical prediction for the amplitude, which they tried to make the experiments for. However, they do not define exactly what's the influence of some quoted parameters, like if I change the frequency, if I change the wavelength, what if I change the depth? And about the depth, they said that the wavelength, they said that there are gravitational waves, and that the wavelength doesn't change if I change the depth of the water, which we don't agree with. They didn't vary the wave source, the water wave source. They didn't talk about the maximum brightness, where should it be. They didn't talk about the geometry. What about if I have a multiple source interfering? Would the pattern be the same, the geometry of the pattern? Would it be circular or would it be straight? And so the positive points of the experiments, they control some parameters like that engine they use to produce the waves. and they took several points of their experiments, although we wanted to talk about the dispersion of points in their graph. They use a mirror, and we think that bad use of the mirror could influence the results that they are taking, like maximum brightness or the other points that are taken. So there are no error analysis that can lead us to a conclusion that the theoretical model agrees with the theory with the experimental data, because some of the points are totally out of the tendency of their theoretical model. We think that they're deviation. So there's no variation of some parameters I quoted before that they should have evaluated, in our opinion, in the theoretical model. And that's it. Thank you for your attention.
Thank you.
Could we talk about the geometry of the pattern? What if I have multiple sources with? Do you think it is the problem asks us to investigate the pattern that is formed in the bottom of the tank? Do you think the geometry of the pattern is important for the?
Well, the problem here is that there is no analytical solution. You have to, in order to calculate the pattern from a random combination of patterns.
I'm not asking if you need to calculate it mathematically. I say, do you think that investigating what the geometry of the pattern will be like was important for your problem?
Yes, and from multiple sources, we will just add to the shifted profiles.
Could I ask you to draw the pattern that will be formed if I have like two punctual sources of water waves?
Yes, of course. This is the way.
Like in the bottom of the tank, if I take the picture from the bulb of the tank, what would be the pattern that I would observe?
From here would be the source. Where?
Yeah, like you have the tank you're seeing from the bulb. Okay.
Yes.
Like and I have one punctual source here producing the wave, and one punctual source here. What would be the pattern that would be formed?
There would be you want to have circular waves?
Yeah.
Okay.
Of course.
There's a here at the bottom. Yeah, of course. For circular waves, yes, well, we have, first of all, this is a 3D Max simulation for ripple or point source. Let me just for a point source of light. If we want to have two sources of waves, we have to just sum up there will be interference of the two waves.
So the geometry will be changed.
Yes,
that's
of course.
The conclusion. But
okay.
I see that the waves are linear. There are no zero. But okay, let's
they are circular, but this is on a slide.
Okay.
So
thank you. What about the gravitational waves? You said that the wavelength. Do you think that the wavelength influences the pattern that is formed in the bottom of the tank?
Well, yes, of course, because the wavelength affects the curvature of the surface, and when
so you have a different convergence of light, right?
Yes.
Okay. You said that you have gravitational waves.
Yes, but in our case.
But in literature, I just finished the question. But in literature, we do know that the velocity of this gravitational wave
changes with the depth. That's well known. Yes.
Yeah, if you apply the same frequency and the velocity is varying, do you agree with me that the wavelength is varying also?
Yes.
So the pattern will change.
Yes.
And in your simulation, actually, you say that you have this here, okay? You have the pattern before, and you have this depth here. And if you vary that, the width of the pattern will be changed.
But in our simulation, we have only the surface capillary waves, which does not depend on the depth.
But you said that you have gravitational waves and secondary capillary waves.
Yeah, generally there's a combination of both, but in our case we have only capillary waves. So your remark is not very relevant. Yes, but
okay. So the gravitational waves will not change linearly. You agree with me?
Yes.
Okay. Thank you for your answer. And what about the interference of the reflected waves?
Yes.
If I have like an interference, would the width of the pattern change?
Interference between
The reflected waves and the produced waves.
I didn't understand your question. If you ask me if we change the geometry of
Okay.
the surface, will the pattern change or what?
Well, I just see the width of the pattern will change, but let's change the topic here. Could you come back to that graphic, the last graphic you showed us?
Yes.
I'd like to discuss it further because
Yes.
I didn't actually understand
Yes.
why you said that your theoretical model works with your.
Because here, as you can see, these are error bars.
This is not. Okay.
Okay, because these are error bars, and how you can see.
Okay,
them?
but
No.
these points and these points, they are totally out of the tendency, and we don't see the agreement with your theory and your experiment.
Why there's no agreement? Because there's like 10% deviation. I can't see why.
10% of deviation, and it is still is out of your tendency.
Okay, but this is experiment where a lot of things are not constant. Like this is only statistics, and in statistics there are some deviations. So
So you have the deviations, and it's also I don't agree with your point, but
okay.
okay. Let's change the topic here. What if I change the frequency of the wave? What will happen to the pattern?
Oh well, of course the product of the wavelength and the frequency is equal to the speed. If we assume that the speed is equal, then the wavelength, if we increase the frequency, then the wavelength would decrease. And
Okay,
if we have
and
the same
decreasing the
amplitude,
wavelength, what happens to the pattern?
the curvature of the water, if we have the same amplitude, the curvature of the water becomes smaller, and the pattern pattern goes upwards. It would be visible.
Okay, but what would change? The geometry,
The width, of course.
the width.
The width and the depth. Because
Okay, thank you. What about you have a dark pattern and a bright pattern. What is the dark pattern? Is the absence of light, is the penumbra area, what is that?
well, as I said, if we have these here,
Do you have a single point of convergence?
it's not a single point for this type of lens, because it is not spherical. It's just an area, and all of the lens, due to the fact that all of the lens come.
It is a single point or not?
No, it's an
No.
area.
So
Well, there is a point with the maximum
I agree that
intensity,
that is not a single point.
but it's
But
an area.
for your considerations, you consider like one single point of the convergence in which the cusp is formed.
No.
And we do not see. It's
use the
kind of
depth.
contradictory.
Yes, we use the depth on which the intensity is the highest.
Okay, so you do see that the convergence is not a single point, so there is a penumbra area and not a
Yes.
totally dark area, as
Yes.
your simulator shows us.
Yes.
Okay, thank you
Yes.
for your answer.
I can even show my simulation if you want. And
Yeah, I want to show that.
so here's.
But before that, could you talk about to me what is the influence of the size of the tank? What would it change?
Well, if there first of all there could be reflections from the walls of the aquarium. Furthermore, the waves the water
What
waves
is the
could.
disturbance of in the water?
Yes,
before
the waves, the water waves could be reflected from the walls.
But just this, wouldn't the okay? This is the equations of the simulator.
Yes. And as you can see here,
But what's the main source of it? Like, where did you get the simulator first?
I read it by myself.
Yeah.
And you can see by the comments which are done, because they are all mine. And furthermore, it's written in Bulgarian, so it's mine. I have done it by
Okay,
myself.
I just wanted to know the background of it, but okay, I don't see. I do see the importance of having a simulator for comparison with the theoretical model, but I don't actually know the.
No, if you want, I can just briefly tell you how it works. It's just there are a lot of the first simulation was just to have a lot of parallel rays coming towards the surface. However, further I proved it by adding just this point source here, and it was very easy to calculate the angle to which
and the capillary waves, what's the influence of that? Because you tell us that there is rotational and there is a capillary waves.
In our case, there are only capillary waves.
Just capillary waves, so you said that there are
there could be gravitational or capillary, but in our case, they are only capillary.
So if they are only capillary, do you see that the amplitude of them are not that big?
Yes, and this can be seen from our
okay, and could it be like diffraction in your problem?
How can
because we just talked about refraction.
Yeah, refraction.
Yeah, you just talked about this now on the refraction on the water surface.
Yes.
So if the capillary waves have a small amplitude, would you see that maybe there could be some kind of diffraction that could influence your pattern in the bottom of the tank?
I don't think so, because first of all, there is no place, there are no obstacles here to have a diffraction, and the wavelengths and the amplitudes were like 1 or 2 above 1 centimeter, and the wavelength is around 500 nanometers. So as you can see here,
unfortunately, I don't agree with your point. I just see the diffraction could be some sort of could have some sort of importance. But in your experiment, actually, you're producing the waves with an engine, aren't you?
With what? Yes.
With an engine. So I do think that that wave is gravitational.
I think because it's all affecting the surface.
So
Thank
I do
you.
think it's gravitational.
He will answer. This will be the last answer. Time was up.
These are capillary waves because they're all on the surface.
Okay.
Maybe 10 considerations.
Yes.
Okay. First, I like to consider that the diffraction could play an important role in the problem, as they use capillary waves as they talked about. But I do think that their waves could be gravitational as well, and there were some variations of the wavelength in function of the depth, and so their theoretical approach in the simulator was not that coherent with their explanations. The geometry of the wave, the wavelength, the frequency were important parameters of the water wave to be analyzed, and because the problem asks us relate the characteristics of the water wave with the pattern formed in the bottom of the tank. And we just do see the evaluation of the amplitude in these experiments. And about experiments, I do see that their points are out of the tendency line, so we don't see the deviation within their theoretical model. They didn't talk about the interference, and thank you for your attention.
Thank you. Now the reviewer.
I'll be asking the presenter first few questions. Do you think you answered? Let's go to the question first. Let's go to the question. Yes, the problem. Before that, do you think you answered? You did justice to this question.
Yes, because
they said study the relationship between the waves and the pattern.
Yes.
Did you study it?
Yes, because we found what causes the pattern and how it changes with change of the waves. So I think we studied the relation between the waves and the pattern.
Have you heard about caustic? Yeah, caustic.
Yes. Yes.
You've heard about it?
Yes.
How does it relate to a work? Does it have any relationship there?
I think yes.
But you omit how? You omitted it. How?
Caustics are, I think that they are light patterns by refracted light from the water surface. I think that they're related to my problem.
Also, do you think damping affects the problem, the experiment? Damping?
No, because it's not so relevant.
Damping is not relevant.
Damping of what? Damping of the waves. Damping of the waves on the surface.
Damping, yes, damping.
Damping on the surface. Yeah, I haven't investigated because I think it's irrelevant to my problem, because here we have to investigate the relation between the waves and the patterns. And from my video, I have seen that the waves have almost the same characteristics along the time, so there's no damping.
Okay. I'll go over to the review to the opposer. How do the patterns change over time?
Over time,
Yes.
like if you have you are continuously applying the wave,
Exactly.
the pattern will be the same because you're continuously applying waves.
On the view.
Of
like
course,
diminish or-
if you have the periods of the wave, would change it would be a periodic interchange between the dark and the bright patterns because of the period of the water wave.
Okay.